I'm not actually going to talk a lot about Cylance. We had a startup that Terry and I created called Spearpoint. We were acquired just recently, so we're happy to be a part of the team. But I actually want to get into the talk because I'm an engineer and security researcher at heart. I don't like vendor pitches, so I'm not going to give one. Okay, so we're Billy and Terry. Basically, what this comes down to is we really like industrial control systems, and we like to find this stuff in various places, whether we download it from the internet or get firmware for somewhere, or buy stuff from eBay. And we like to own it. And then what we do is just kind of rinse and we repeat. So at some point, well, let me go to the things. So Dale, thanks for bringing us out and the entire S4 crew. It's always an honor to be here and watch all the presentations. I'm always humbled when I see the other researchers and their research that they present in S4. It's really cool. So ICS cert, this is actually an important piece. So we discovered some vulnerabilities, which we're going to show you. And after we discovered these vulnerabilities, we actually didn't know what to do with them. We didn't have any points of contact in the healthcare field, especially with the organization that we found the vulnerability in, or whoever owns that product. And so on a phone call, we reached out to ICS cert, and they said, hey, this is kind of out of our lane, but we think we know some folks over there. We could probably contact them for you. And we said, hey, you know what? That would be great. And then a couple days later, they actually sent me an email saying, hey, Marty Edwards is telling me that DHS and ICS cert will actually be the lead cert to deal with medical device security and software security. So if you find any vulnerabilities in medical devices or software, ICS cert is going to be the lead for that. And I think some of those folks are here, and they'll probably be able to answer those questions regarding that better than I will, because like I said, I just found out about that last week. But I thought that was pretty interesting, and I wanted to make sure everyone knew that. In our case, it actually worked out really well. So the story that I'm hearing is that when we told ICS cert about this vulnerability, they actually didn't have a point of contact readily available at the organization. Instead, they talked to a receptionist, and they eventually worked their way up to the right people. So that's not something I think Terry and I could have done on our own if we contacted some receptionist and said, hey, we want to talk to your C-level people and people who own this product. But they could. And another thing is I think somehow the FDA is now involved. So, and someone had actually recommended that we contact the FDA with regards to the vulnerability. And I actually was not comfortable with that. First off, because I don't know who to contact there. I'm a little bit leery of sending a proof of concept exploit to the FDA just kind of randomly, especially if they don't know who I am. And then the last piece is I don't even know if they're really structured to accept that kind of submission from someone. So we didn't contact the FDA directly. We contacted ICS cert, worked through DHS, and then now I think all the right players are in play. So, and then all the other like industrial control systems researchers at S4, we're always inspired by your research. It's always great to watch and see what you're doing. We're humbled, and we drew a lot of inspiration from your work actually. So if we see you at the bar or whatever, your first drink's on us. So the lay of the land, the way we actually came across some of this stuff is when we looked at some of the major vendors that are in the ICS space, we realized that some of those vendors actually are the same people in the healthcare industry, right? So you can actually just say, hey, ICS, medical devices, and software, a lot of the big vendors are the same people. And so what we wanted to understand is whether or not the practices that they used in developing their software and their hardware and their firmware carried over to the medical device world. And obviously it does, right? Obviously it does. They don't change habits when it comes to that sort of stuff. So, but I think more importantly, the mentality that we see and some of the attitudes that we see towards security and developing a life cycle and such, it's exactly the same, right? And so I think eventually what we'll be able to do is overcome the technical challenges, which are great. Don't get me wrong. Like there's a lot of code that needs to be fixed. There's a lot of stuff that needs to be adjusted, and there's a lot of process stuff that needs to be put in place. But I think those are technical problems. And I think at the end of the day, we'll be able to work through those problems and actually solve those problems. What's more difficult, and I think we're struggling with this in the ICS world, is the mentality there, right? Shifting that mentality and the culture and making sure that everyone understands that this is a technical problem, but it's also a people problem as well, right? These organizations approach these things in a way that we really don't like. And I think this is evident in the medical world where if you talk to a nurse, for example, I don't want to name any by name, but we know some. If you talk to them and you ask them about this software and you ask them about these devices, they'll tell you that they're really crappy. from a reliability and a security standpoint. They don't even know what security is, in a traditional sense. They're not security researchers. But if you just have a casual chat with them and go, yeah, what's your software like? They very rarely have good things to say. It's always crashing. The device is really weird. It goes offline at random time, that sort of stuff. And that stuff interests us. And it's not like they're not aware of this kind of thing, right? They are aware of this thing. People do know. And I'm surprised that nothing's been done about it. And I think this story is very familiar to people who are doing research in the ICS world. And so maybe what we can do is convince some of you to go over to the light side and start looking at medical devices and firmware and software. That'd be pretty neat. We hope a lot more people start looking at this stuff. So we did run into some roadblocks. So the initial roadblocks, it's mainly obscurity, right? Obscurity. Finding the equipment and software is actually a little bit challenging for a variety of reasons, and we're going to get into that. But I think the same is true for some of the industrial control system stuff. And then once you kind of get into a rhythm or a flow, it becomes easier. And we'll talk about some of the stuff that we had encountered along the way. Some of these devices and software, they actually use custom protocols. That should not be a surprise to anyone who works on ICS. Obviously, some of the protocols they use by design have no authentication. That should not be a surprise to anyone who works with ICS either. And the last piece is we're actually scared to talk to some of these vendors. And we found ourselves in the same situation when Terry and I started doing ICS stuff. And that's why we funneled everything that we had through DHS. Because it's a little daunting when you don't know a company and they're kind of old school and you see that they have a lot of obscurity in place and you start sending them like Metasploit modules and proof of concept exploits to some weird mailing address that has nothing to do with security saying, hey, I need to talk to someone about this. So we were a little scared of the vendors. And that's why we end up actually eventually going through DHS. So when we talk about obscurity, we call this reindeer games, right? Because we're Rudolph and the other reindeers don't want us to play, right? And they have all these scary things that they're telling us. They're saying, hey, look, you can't buy this stuff. We're not going to sell it to you. We're not going to give this to you. We're not going to let you buy this. We don't care that you're a security guy, whatever. And we thought that was pretty interesting. In fact, the first couple devices that we tried to buy, no one would actually sell them to us. The first thing that we tried to buy was actually an X-ray machine. And the people were like, you need a license in order to have radioactive material. And so we said, can you just sell it to us anyway? And they're like, no. What about the software? No. And we're like, okay, obviously no radioactive material. Then we tried to buy a surgical laser. And they're like, no, this class of laser requires a license. And we won't sell this thing to you. And we're like, oh, what about the software? No, we're not going to sell you the software. And then it just kept going on and on, right? So I don't know if these things are in place to stop security researchers. I don't think that they are. I think they're more in place to stop random people from buying an MRI machine who's not qualified to use it, go set up shop somewhere and start offering people $5 MRIs for stuff, right? Because that's not a good place. But this will be an obstacle that you will encounter if you decide you want to look into this kind of stuff. So you will face this, and you will encounter this if you want to try to get a device or this software. So, and there's all sorts of rules. And I'm not saying that I understand the rules exactly, perfectly, or anything like that, but I'm saying that you will encounter this if you want to look at this kind of stuff. So, with that said, we're not doctors. We don't have licenses, but we do watch a lot of House, and we did stay at a Holiday Inn. So, and there's nothing that can really stop you if you really want to get this stuff, right? Eventually, you're going to find some hardware or some software or something that is kind of maybe on the edge, or they don't know if it needs a license or not. They want to make some quick money, a reseller or eBay or whatever, or someone happens to get a hold of this software, or you'll find it on a website someplace, and you'll be able to actually get some of this stuff, right? And that's gold for us. And then once you kind of figure out the lay of the land and how this thing works and where you can get this stuff, it becomes very easy, right? It becomes easier to acquire this. Not easy, but it becomes easier to acquire this kind of stuff. So, I mean, we also have firmware and support software that technicians will use to go diagnose specific pieces of equipment or whatever. Once you kind of know what it is that we're looking for and under what circumstances they'll release this stuff or where it can be found, it becomes more straightforward to get this stuff. So I had this thing mailed to us. The device that I'm going to be talking about today is called an Xper. It's made by Philips. It was sold to me by a reseller. It was only a couple $100. I've been buying a lot of ICS stuff and had medical stuff delivered to my home. It was delivered to my home address, which is just residence in California. And my wife hates that all these packages show up and they're never for her. But I ferried this thing into my office. It was huge, like this giant box, right? I'm like, oh, that's awesome. So I took it into my office, told my kids not to touch it. And then later on, after I put the kids to bed, we opened the box up. And then what we noticed is it had all these inventory tags on them. So, and the inventory tags actually stated that this was actually once the inventory of a hospital in Utah. Well, very well-known hospital. So upon seeing that, I took a step back and thought about it for a little bit. And what I did is I pulled out some forensic software and said, and then basically this thing's just a blade, like a Dell blade, but it's I think it's actually put together and configured by Philips because it's got all the Philips branding on it. But we took out some forensic software. We made an image of the hard drive on there because we had no idea what to expect or what could be on there. We wanted to make sure everything was done the most appropriate way. So that took one night. The next morning, we started banging away against this thing. So first thing we realized is that this thing is not running a proprietary operating system. It's actually running Windows XP. So that sped things along for us very, very quickly, right? We know exactly how to slice and dice that, or any Windows operating system. We're very familiar with it. So we dumped these creds here, right? And we're not sure, at the time, we were not sure whether or not these were like Philips service creds that were used by technicians. But we actually talked to DHS and ICS cert who had talked to Philips, who gave them these creds. Philips is saying that these are not hard-coded creds that they build into these things. But if you're ever on a hospital or anything like that and you come across one of these devices, I would check just to make sure that this is not a technician or service thing that gets baked in somewhere along the way. But even if it's not, these creds belong to some hospital in Utah. So that's why we're not going to tell you which hospital it is. We've told DHS, obviously, and I think the FDA knows. But it's not good, right? So not good, but very easy to get. So the next thing we did is we crafted a very sophisticated buzzer, which is this. For those of you who don't understand what this thing does, it just connects to a port and just throws a lot of A's, capital A's, at the open port, right? So this took us 3 days to write. Once we got this written, we decided to use it. Yeah, just joking, just joking. We actually had this previously written for ICS software. It was named after some other vendor. We just renamed it and then launched it, right, against the open port that we saw. And so what we saw is this, right? And so looking at this, we're like, wow, this looks really a lot like a heap overflow. So that's kind of neat. And so we're actually going to show you that. We're going to show you like the results of this so you can kind of get a feel for what's going on. And we have the software running in a virtual machine. Like I said, it's just Windows XP. There it is right there. So we wrote a proof of concept exploit for this thing. It's just a Python script. I don't know if you can bring it. I can't see the other. If you want to bring the handler over. Yeah. So there's the Metasploit. All we do is we just have a handler listening. And then our Python script actually just exploits this thing, loads a interpreter, shellcode, interpreter reverse TCP. So you should see it once we launch the exploit here, connecting back here. So. Yeah, just hit enter. Yeah. So there we go. We've got the stage there, and then the interpreter session's open. But we also want to show you one other thing. Once you own this thing, you own this service, it's actually running as a privileged service. So you actually own the whole device, right? Exactly. Yeah. So anything else that's on this device or anything else that's connected to, or anyone else that's logged into this thing, they're owned too, right? And I think by design, these things connect to a database. 3. Yeah. Yeah. And then just do a hash dump real quick just to show that the interpreter session is privileged. Yeah. See? So that's just to show you that it is a privileged service. So anything that's connected to this device is basically owned as well, right? Or any hashes that are available, we can start passing those and start escalating through the network. So, yeah, I mean, we made it so that that thing doesn't recover yet, you know. So, but given the nurses that we've talked to, there's probably a pretty common thing. We're like, oh yeah, it can crash again, so we'll just restart it. Terry's going to talk to you about some other stuff that he found more at the design level, but we just wanted to make people aware of this kind of stuff. Like I said, I think that the technology and the stuff that we're encountering from a technical standpoint is the same, but more importantly, I think from the mentality and the mindset standpoint, that's the same too, and I think that's a little bit dangerous. So we're not going to release the exploit because obviously it's not fixed. They're checking to see whether or not the latest version that they have, which is 6, which I don't think is released yet, is vulnerable to this, but they don't know yet. So, yeah.
Grab that mic.
All right, sure.
Okay, can you hear me okay? So one of the other things that we noticed is in the ICS industry, there's a lot of not only vulnerabilities from poor coding, but there was also a lot of just bad practices, right? So not necessarily being designed with security in mind, making poor decisions when it comes to actually implementing the products, right? So we were wondering if there was a similar parallel in the medical industry as well. And we started doing some research, started looking at the internet and seeing what's out there. And, everything is advancing, right? Everybody wants to have the newest technology. Everyone wants to have an iPad. Everyone wants to have it mobile, right? So upon a little bit of research, there's a company that have a pretty good market share for monitoring units, okay? So you go into a hospital room, they have the monitor with the EKG and the heart rate and blood pressure and all that, and it's piped back to a central monitoring station, okay? The thing is that device is still running an operating system. It's basically just a computer. It has a piece of software on it, and people want to be able to access it. So after doing some research, we find this iPad app, right? And basically, it's designed so that a doctor can monitor his patients. So there's emergency room, intensive care, medical surgery. They want to be able to do all of it from one location. They've got all their patient info right there. Get into a little more, great graphs, designs. I mean, it's a sophisticated looking piece of software. It actually, I was pretty impressed. But then I started thinking about it, right? And I started thinking about like common practices in IT that you just don't do, right? And you see the list, but I mean, sharing or RDP over the internet, suppose you can. It might not be necessarily a really bad thing, but it's not a best practice and it's not recommended because it's giving people access to your equipment. You don't share passwords or accounts, right? You try to keep unknown people off of your machine, and you want to, if you do allow unknown people onto your machine or onto your application, you really monitor and control what they can do, okay? The key is you don't trust users ever, right? So enter the iPad app, right? Start looking. First thing you notice, it uses RDP to connect from an iPad to this host on the internet. Like, that's brilliant, right? So then it's like, well, maybe they at least changed the default port. No. So there's a RDP host, or there's Windows host running RDP, listening on the internet. You can do any kind of configuration you want there. All right, so now we look at, RDP's done, so we already got that. But what about sharing accounts? Well, if you notice here, negotiating credentials, users, VIP sales, it's already negotiated, right? This is after downloading the app off of the App Store, okay? I didn't have to do anything. This is their demo server, okay? And I've seen demo accounts. I understand you want to be able to demonstrate your stuff, but most companies, they have the mindset of if you want a demo, you email us and we will email you back credentials, or you sign up on a form and we email you demo credentials. So that right there just tells me that they don't have that security mindset, okay? And of course, sharing passwords, like I said, it came pre-baked with it as part of it, but that's a pretty bad practice, right? If you notice here, store credentials. So anybody who's carrying around this iPad app, they're probably not going to log in ever. This is going to do it for them automatically. So, okay, that's just general IT practices. And now we don't want to allow unknown users on our machine, right? Well, when you log in, you basically get this, right? So now they don't know who I am. They don't know where I'm coming from. They've given me shared credentials. They're letting me log into their RDP session. But they've done a great job though, right? Because when you log in, they've actually set it up so that it runs their application. And naturally, you're stuck in that application, right? It would make sense. So then you start looking and there's like, remote program, what is that in the configuration? I'm like, that's very interesting to me. What would you possibly do with that? And then you look here and it's like, oh, it's running C program files, their application. Huh. Okay, so what would I possibly do with that? And they actually have really interesting swipe features. So depending on how you swipe your fingers, you can do all sorts of crazy things with this application. So 3-finger swipe opens up the keyboard. At first, I didn't realize that, but then, once I figured that out, it's like, okay, so I actually have an interactive session with the keyboard to use on this server. I didn't know what would happen if I tried this, but just being curious, I had to. So if command prompt, we'll see what happens, right? So now we know that they're letting an unknown user run on their application with pretty good rights, and the big key is, do they trust me, right? Turns out they do trust me quite a bit. I'm not a malicious guy. I would imagine the server's probably already owned. I have no idea. I have no way to tell that. But all I did was get the host information and who am I, right? So I'm running as a user on this test server that they have on the internet, running RDP that they let me connect to and run any application I want, right? So there's no bounds checking there. They're not actually restricting me. And to me, this is just, it creates the same parallels, right? You cannot trust users. You cannot let people connect to your machine if you don't know who they are, or you should at least make sure that they are required to stay within certain parameters, okay? At least make it difficult. So that's basically our talk. All we want to demonstrate really is that for the researchers and the people who are looking at the industrial control system space, the same vendors play in the medical space. The same software practices, poor coding, design flaws, poor security practices, they carry over into the medical space. And it's a lot harder to get software or equipment, but for us, it was just a very interesting parallel. So that's what we had, and hopefully, if people are interested in learning more or looking at it, go ahead.
Some questions and comments. Sir, again, if you want to connect up.
Great presentation. Darren Highfield with Utilisec. Great presentation. Thank you. Wondering more from the I guess the doctor or medical facility staff or more importantly, medical facility management. Wondering how much interaction you've had with those groups of folks and what kind of touch points or sensitivity points, what do they react to in terms of, how do you get past the well, why would somebody want to do that kind of conversation?
I think, we get the same questions that we initially got when we started looking at the ICS spaces. Why would you do that? Why, and I think as a security professional, as somebody who's been doing pen testing for a while, that's actually a common question. Whether it be an engineer on an IT network or an application engineer or anybody who's doing anything in the IT space, when you go in and you test their application, and you find something they didn't expect, why would you do that? Well, that's what we do. We challenge assumptions. You assume that your software is safe, and so as far as the reaction so far, when we actually talked to ICS CERT, and the reaction from Philips was very positive. Right? It did not take them long to get a hold of the people who were in charge of the product. The people in charge of the product immediately came back with a response, and they're working on it. So for us, I think it was really impressive.
Yeah. I wonder if the response is so quick because the FDA called them. But personally, when I see this stuff, this is just my personal philosophy. I don't think we should blame the users, right? Like, I don't think that nurses should be security experts and understand, how to hack and write buffer overflows and heap overflows for expert, right? So they're expecting this software to do certain things. And I think they just kind of assume, as far as the users go, they kind of assume that it's okay, right? Like someone can't just easily gain access to this stuff. That the application that they're using to monitor their patients is not an RDP over the internet with shared creds on every single iPad in their hospital, right? Where anyone can gain access to and run whatever they want to run. And so they're not engineers, so there's a little bit of difference between us and the ICS world, where I think most ICS folks that are running this stuff, they're actually engineers, right? But these folks are just like nurses and doctors, and they don't need to understand that stuff. They don't have computer science degrees. They have a different focus. So I would like to see, more work from the vendors, right? And say, hey, when someone installs this software in a hospital, they don't need to worry about the most straightforward, obvious problem that a threat model would identify as the first threat, right? Like, hey, that port that you're listening on, can it be remotely overflowed by a straightforward heap overflow and exploited? And when they exploit it, you gain system to the box. And then from there, it's escalation exercise from there, right? I mean, that's just my philosophy, but I think we need to help those guys, not say, hey, it's their fault. And so when I say mentality, I mean really more of the people making this stuff, right? The people producing this stuff. So.
Okay. Well, I had a comment and a question for you. The comment was the credentials were very similar to what you see in the ICS world. Like there was, a case that came out where Siemens was instructing everyone who installs a turbine control systems to use this account in the switch.
Right.
So, and that document got on the internet and it got pulled off, and supposedly that solved the problem. But if you go out there, probably all those systems are installed the same way. And I would imagine that's true in medical systems as well. The installers are doing exactly what they're told to do.
Right.
The question I had is, have they given you any, Phillips or anyone else you've talked about, they given you any indication as to how they would roll out a fix and how successful, like, do they have the same problem that these things are installed and never updated, or do they get updates every quarter anyways for other reasons?
We didn't talk to them about their update process. I don't have a lot of confidence there, to tell you the truth. Based on the response and the way that they're trying to figure out whether the latest version is vulnerable, I don't know. So what I do know is that when we purchased this device, like it seemed like they configured and set this device up and it had their branding on it and their stickers on it. So I didn't see any weird phoning home from the software to see if there's updates or anything like that. And in fact, when I went to their websites to try to find more information, there is no information like that about that on there, right? So if you try to search for vulnerabilities in this specific software device, like you will not see anything about it anywhere. So I don't have a lot of confidence there that they do.
Matter of fact, there's not even, contact us about a security bug or anything like that. So that's part of why, we end up going to ICS cert, is because in this space, like it doesn't seem like they've even began to be security conscious, right? So maybe there's people in here that has been doing pen testing, for hospitals for a while, but the vulnerability research isn't being done because it's so restricted, right? The same vulnerabilities exist, but I don't think the obscurity is going to help, right? If somebody wants to get this, they'll get it.
With that, if you're dating a nurse or would like to date a nurse, you should come talk to us afterwards. And
Okay, well that's a perfect place to end. Thank you very much, guys. That was great.